Setting the calibration output level on the instrument. For more accurate results, the nominal calibration level of 114 decibels should be changed to the actual output level of the calibrator with the appropriate corrections applied. Please keep in mind that the corrections are very small. They are typically less than 0.2 dB, and that most users and applications do not need to be concerned with applying them. To change the corrections on the meter, first tap the settings icon on the instrument. Then we're going to select the measurement settings. Then we're going to select the calibration settings. And then we're going to tap on the calibration output to change the level, and this is where we input our new value. The new value is determined using the following process. First, we're going to start with the value listed on your specific CAL150 or CAL200 calibration certificate, and then we're going to apply an additional correction of negative 0.12 dB for 1/2 inch free field microphones to the value listed on your certificate. This is all that is needed for most applications, and we can generally stop here and input this value as the output level of the calibrator on the meter. However, when measuring in extreme environments, those that differ significantly from standard temperature and pressure, additional temperature or pressure corrections may be needed. I will discuss this more later in the video. Microphone corrections. The default setting for this instrument is free field to free field corrections, which provides the most accurate free field response for this instrument with or without the WS001 windscreen. Here's the free field response of the A21 with the 377B02 microphone. The free field response without the corrections is in orange, and the free field response with the free field to free field corrections is in blue. Advanced calibration. In acoustic calibration, the sound level calibrator, in this case either the CAL150 or the CAL200, provides an acoustic signal of a known amplitude, 94 or 114 decibels, and frequency, 1000 Hz, to the microphone, which is used as a reference to adjust the system sensitivity. In the meter, the system sensitivity updates with each calibration. We recommend that you calibrate prior to each measurement. Transporting or even repositioning may introduce vibrations of the temperature and humidity, which may impact the accuracy of the meter, microphone, and preamplifier. When the sound level meter is not used near a reference environmental conditions, then corrections will need to be added for the ambient temperature and the prevailing static pressure. Check the calibration data shipped from Larson Davis with the calibrator to get corrections for the influence on the calibrator output level. Pressure to free field calibrator level corrections when using the CAL200 to calibrate an instrument with a 1/2 inch free field microphone. An acoustic calibrator creates an acoustic pressure field of a known amplitude. The 377B02 and the 375A04, which are the standard microphones for the 721 and 821s respectively, are free field microphones, not pressure microphones. So a small correction to the output level should be applied for the most accurate acoustic calibration. The CAL200 provides a nominal pressure level of 94 decibels, or 114 decibels. The exact levels are printed on the Larson Davis calibration sheet that came with the calibrator. Here's a sample calibration sheet for demonstration purposes. This particular calibrator has an actual output level of 114.2 dB at standard temperature and pressure. When using a free field microphone, the pressure level at the microphone diaphragm will be slightly different. Thus, a free field correction factor of negative 0.12 dB should be applied to either of these levels. In our example, the calibration sheet for the CAL200 indicates an output level of 114.02 dB. Then we set the cal level into the instrument to 113.90 dB and 1 kHz to account for this offset. However, the pressure and random incidence microphones do not require this correction. Please keep this in mind when switching microphone types, and if necessary, remove the negative 0.12 dB free field correction offset. If the calibrator and instrument are near room temperature, which is 23 degrees Celsius, and near sea level, which is 101.3 kilopascals, then no other corrections need to be made, and we can set the calibrator output level on the instrument to 113.90 decibels. Please remember that the output level of your specific calibrator might be different, so this 113.9 dB is not applicable for all cases. Temperature and pressure corrections. When the microphone and instrument are at a temperature other than near room temperature or static pressures not near sea level, then corrections will need to be added for the ambient temperature and the prevailing static pressure. The microphone's sensitivity varies with static pressure. If the instrument is calibrated in one environment and moved to another, then the sensitivity will change after stabilization, depending upon the change of temperature and pressure. The coefficient of static pressure is typically negative 0.013 decibels per kilopascal for PCB 1/2 inch free field microphones. The sensitivity of the microphone varies slightly with temperature also. The coefficient of temperature is typically negative 0.009 decibels per degree Celsius for PCB 1/2 inch free field microphones. For example, if the system is calibrated at 18 degrees Celsius, then it will be 0.05 decibels less sensitive at 23 degrees Celsius. Check the calibration data shipped from Larson Davis with the CAL200 to get the pressure correction specific to your system. Here's a sample calibration sheet showing the output level change over a range of pressures for demonstration purposes. The corrections can be added to the level obtained in the previous step to get the actual level of the CAL200. For example, if the nominal pressure of your calibration environment is 65 kilopascals, then we add negative 0.05 decibels to the free field corrected output of 113.90 decibels at 101.3 kilopascals obtained earlier, resulting in an output level of 113.85 decibels at 65 kilopascals.